We talked about the basics of lists in the last video, and the list is a very simple concept. The power of a list comes from its operators, functions, and methods, which is what we're going to talk about today. And in particular, I want to talk about indexing lists with slices, extending versus appending, length, sort, and reverse. Let's take a look at this one by one. Let's first create a long list. As we know from before, we can create a long list with range 50. Actually, we need to call this a list, otherwise we just give us a range. Long list, a big list of numbers, right? The first thing I want to talk about is the slice notation. A slice notation works like this. We have long list, and we can have elements 0 to 4. What this means is, with a slice notation expressed as a column, we can have the start index and the end index and everything in between. So we can select the elements 0 to 4 by using the slice notation. We can equally say 4 to 40 with the slice notation. We can also specify the step. So we can say 0 to 10, and then we can say 0 to 10 with a step 2, which allows us to capture the numbers or the elements from index 0 to index 10 with every other element skipped. We can make it 3 as equally easily. The other thing we can do is we can have only one side of the slice. So we can have 5 to go from 0 to 5 implicitly, and we can have 5 to the end, which gives us element 5 all the way to the end. We can also use minus. So minus 1 is the last element in the list. We can get the last 5 elements in the list by starting from the 5th last element, getting the slice notation and putting it as the end. So that's how you use the slicing notation to access the list. As you can imagine, this can become very powerful because there are so many combinations you can put in it. You can even put variables, so we can have start index equals to 5 and end index equals to 10, long list, start index, end index. Because we can assemble these variables with infinite complexity using for loops and if then else statements, we can very smartly divide a long list using the slice notation fed in by some variables. The next thing I want to talk about is extending versus appending. Let's revisit our nested list. And actually, let's make our nested list something different. So now the nested list is no longer nested. But what we can do is append a new list to nested list to make it a nested list again. So what we've done is when we call the append function, nested list gets a new element, and the element's value gets whatever that we feed append. But what if we want to, add a new list to the existing list? We can do this in two ways. We can use the extend function, which as you can see has extended the list with the elements in the list supplied to extend instead of appending it as a single element. Or we can also just add some elements using a list like this. If you want to use the addition notation or the operator to add a sublist inside nested list, we can give it two lists, and now it has added a new list. The other thing to notice is append and extend works in place, so nested list is actually transformed by append and extend, but the plus operator creates a new list instead of operating on nested list itself. So here this is a new list, and if we don't save it in nested list, the results are gone. As you can see here in in34, we've added 7, 8, extending nested list, but then now in in35, when we're appending 7, 8 again, what we have done in in34 that's seen in out34 is gone. What we actually need to do is do nested list, and then you can see that we have now reassigned the results of this expression into nested list, extending it before doing another operation to append a sublist of 7, 8 to nested list again. There are other things we can do with list. We can see the length of the list by doing len, nested list, and that gives us the length of the list. Recall in the section about loops where we had to manually specify when to stop the for loop or when to stop the while loop. With the length, we can actually just say if the current index is smaller than the length, we'll continue iterating through the list. The other thing we can do is to sort lists, so we can have unsorted. What we need to do is do unsorted list.sort, and again, because it's a list function, it affects the list directly in place. We don't need to assign it to anything, and we can call unsorted list again, and you can see that the positions are now sorted. We can reverse this, and that's all there is to it. So we have learned about indexing lists with slices and the difference between extending and appending. I showed you two different methods of extending and appending lists, one with the functions, which affects the list in place, and one with the plus operator, which does not affect the list in place, meaning you need to assign it back to the old variable to update its value. We talked about the functions length, sort, and reverse. In the next video, I'm going to introduce the dictionary data type. I'll see you guys next time.